After you log in and select your app, you're greeted with the overview page. This is your home base and a great jumping off point. We can easily adjust the visible time frame to select relative times or select specific times in the past. We'll expand our view to look at 60 minutes of data. This chart is fully interactive. We can select different metrics below and the line will update instantly to show how this metric changes over time. Additionally, we can toggle on and off different bar segments. Another simple way to focus on specific times is just select a segment on the graph. You'll notice that the metrics and insights will live update to reflect your selection. Highlighting a period on the chart will pull up the most interesting views, endpoints, or jobs during your selection. We can see them sorted by max response time or largest memory increase. Now we're in the web endpoints view. This is how you would see your Django views represented as well. Every instrumented sub-event or method call is broken down into the most relevant and sorted by average time consumed as default. These values are averages for all observed hits on this endpoint over the selected time period. When we click on methods that interface with a database, we're able to see the specific SQL queries executed. This is cool because Django obfuscates the underlying SQL via its ORM, so this gives us a great look under the hood. We can see from the chart that it isn't SQL, but clearly HTTP requests that are taking up the majority of our response time. We'll take a look at traces to learn more. These are full breakdowns of specific instances where this view or endpoint were hit. Since this is just a basic demo application, our traces are very simple, but you'll get an idea of their power. Now we're in the timeline view. Clearly, the HTTP GET request is dwarfing anything else happening in this trace, but we'll expand the view to show everything, including those fast SQL queries. With our GitHub integration, we can see the exact code that was executed, and clicking on this will open the source directly in GitHub. We've set up some custom context on this request, which will show in every trace on this endpoint. In this case, we're recording the user's email, name, and location. Let's head back to the overview page and take a look at the insights Scout provides. This N+1 Insight tab highlights areas where we detected N+1 database queries. These are easy to miss in a Django application, but can be just as easily fixed by eager loading, such as by using the select related method. Doing so can provide a huge performance boost to your applications. Clicking on the insight will take us to a specific trace where we detected the N+1 query, the red badge marking the spot. Again, we're able to see the SQL statement and backtrace. In addition to N+1, Scout will also automatically detect and highlight slow queries, find any memory bloat, as well as gather errors. We store a history of all generated insights as well as their associated traces. The Web Endpoints tab shows all the API endpoints and Django views, initially sorted by overall time consumed for the selected time range. Same goes for the background jobs page. This is a simple celery task I added as an example. As you can see, it uses Redis and SQL, though the vast majority of time is spent in Python. The database view lists queries ranked by consumed time, showing throughput and average response times, as well as anomalous database events and usage spikes. Again, we're able to see the exact SQL statement and which view, endpoint, or job is running it. Remember, we can always select a specific period on these charts to focus on interesting data, and these selections will carry over to all other views. To show that, let's take a look at the External Services tab. This ranks and charts the consumption time and throughput of external services grouped by the endpoint, view, or background job which reached out to them. Again, in this example app, we're only reaching out to this random user generator API. This is the errors view, which consolidates all the error types that have been seen, charting by both type and endpoint. Looking at this key error, we can see the count of occurrences, view the stack trace, and add comments for other users in your org. We can click Explore to see traces of each error's occurrence, or mark the error as resolved. Scout supports alerting with custom conditions and notification groups, as well as built-in SLA reporting. We hope you see how Scout provides easily understood, actionable insights, clean and quick charting, and powerful trace analysis. Scout gives developers the power to quickly identify and address hidden performance bottlenecks.